So let's look at our first equation, or trig equation, to solve. We've been asked to solve sine x equals 0.3 in the range 0 to 360 degrees. So how are we going to do it? Well, basically, we've got our sine graph drawn, okay? Notice the range is from 0 to 360, so all the answers that I'm going to write down must be between 0 and 360 degrees. So which part of the graph am I interested in? I'm just interested in this part of the graph here, okay, because that's what my range is. Now if you imagine we've got the graph of y equals sine x, what have we replaced y by? We've literally replaced y by 0.3. We're saying sine x is equal to 0.3. We're trying to find all the angles that we would replace in here to make 0.3. Now the technique of doing it is if you go to your graph and you look at this axis here, what we're going to do is we're going to draw a line at y equals 0.3. Now because it's only a sketch, it's a sketch of the original graph, we don't have to be brilliantly accurate. I'm just going to draw a line in here. I'm going to say there's my 0.3. I'm going to draw a line across like this, all the way from 0 to 360 degrees. And basically what I'm doing, I'm seeing where that line cuts my sine x graph. Where does it cut? It cuts here. It cuts here. It doesn't cut anywhere else in the range 0 to 360. So I'm expecting two answers, okay, which are going to satisfy that equation. Right, now how do I get my first answer? Well, my first answer comes from my calculator. Remember the technique when we did trigonometry? How did we get rid of the sine? We did sine inverse. So the same thing would apply on my scientific calculator. I would literally go and do sine inverse of 0.3. Make sure you calculate it in degrees, okay? And that comes to 17.5 degrees. I've rounded to one decimal place. One decimal place will be enough to do this question. Now, because I've drawn my line, what does that represent? That tells me that that cut there is 17.5 degrees. It actually tells me that that part of the graph there is 17.5 degrees along this axis. Now all I've got to do is try and find where it cuts again. It actually cuts again here, and because this graph is symmetrical, that little area there is 17.5, also makes this little area here, going to that 180, also 17.5 degrees. So this next cut would be 180 degrees take away 17.5, because the graph is symmetrical between the 0 and 180 degrees. So the calculator is giving one of my answers, but there is more than one answer. When we were doing trigonometry, it didn't matter, because when we were doing trigonometry, we were dealing with right angled triangles, or we were dealing with triangles when we did the sine and cosine rule. So that is the answer I wanted my calculator to give me, was something in that range of 0 to 90 degrees. But there is more than one answer. When you press that sine inverse, there's a whole range of answers. Just think about it. This graph goes on forever. There'll be another cut here, and there'll be another cut, and another cut, and another cut. There's loads of cuts along here. There's a cut here. There's a cut here. There are loads of different solutions to sine x equals 0.3. Your calculator is just giving you that one. But there are others. I've just proved there's another one here. So what am I going to do? I'm going to do 180 degrees, take away the 17.5. 180 take away 17.5 degrees will give me my other answer. So that comes to a grand total of 162.5 degrees. How can you check you're accurate or correct? Now remember, I've rounded these to one decimal place, so when you go to your calculator and type in the sine of 17.5 degrees, you will get an answer very, very close to 0.3. You won't get exactly 0.3, but you'll get an answer very, very close. Same applies if you type in 162.5 degrees, sine of 162.5 degrees, you'll get an answer which is extremely close to 0.3. Okay, what we're going to do now is going to have a look at a trig equation involving cosine.